Hello, welcome back to my channel. Hope you are doing well. Today I will make a video about how to calculate of your electrical data of your p-part nanoparticles. I hope after watching this video you can easily calculate of your electrical data, which is provided by the impedance analyzer. Suppose you have a nanoparticles powder form, you have a make a pellet and also measure the electrical data. You can see here, this is my electrical data. If you want to see here, this is my electrical data of my nanoparticle sample. You can see here, this is the frequency, this is conductance, and this is resistance of my pellet sample nanoparticles. And the other one is, you can see this is the data for capacitance and other parameter. You can see here, this is sample 2. This is also have 3 frequency, capacitance and D factor. So how to calculate this parameter and plot of your electrical data, which is also plotted by the Origin Lab software. Here you can see my electrical data. Now you can calculate this electrical data, various parameters such as impedance. You have to need dielectric constant. You have to need relative permittivity. So how can we calculate it from this data? So for the time shortness or limitness, we also made this Excel form. After watching this Excel file, you can easily calculate it or convert it this parameter easily. At first, you have to see here the frequency, which is hertz unit, and another was log f. So converted this frequency hertz unit to log f, you have to use, here you can see the formula equal log A2. Here A2 means the frequency, and the capacitance. This is the important parameter for electrical data. This is the capacitance, farad unit. You can see here, this is the capacitance. From this data, we can, another parameter is thickness, Cp into D. You have to see here to how to get the thickness of your parameter of your electrical data. You can see here the C2 into 0.001382. Here 0.001382 the thickness of your pellet, and the C2 means capacitance. You can see here, this is the formula. You have to use this formula to compute this parameter. And another one is E naught A. Here E naught is a constant value, which is, you can see here, 8.85 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 8.85 into 10 inverse 9, and this is the area of your pellet. So if you have a cylindrical pellet or hollow pellet, you have to easily measurement. We also know that the area of a circular pellet is pi r square. R is a radius. Now we have to calculate the real part of permittivity, we indicate E prime. So how to calculate this parameter? So you can see here d2 divided by E2 equal d2 divided by E2. Here d2 means the Cp into d and divided by E2. Here E2 means E naught A. We also measure this already, and if you want to use this formula, you have to easily compute of your real part of permittivity. This is the another parameter. You can easily calculate this 2 pi f. We also know already 2 is a constant, pi is a constant value, 3.1416, and here A2 means frequency. And another one is conductance. This is the important parameters. Conductance unit Siemens. Here you can see, you also get this data from the electrical data, which is measured by the impedance analyzer. And another was parameter is tan delta. Tan delta, here tan delta indicates the dielectric properties of your electrical data, electrical parameter, dielectric properties. How to calculate this tan delta or dielectric properties? Here you can see the formula equal S2. Here S2 means conductance. This is the conductance divided by G2. G2 into 8.85 into 10 inverse 9 into F2. Here G2 indicates the 2 pi f value. We also already measured this value, and you have to need the constant value. Here G2 indicates 2 pi f. This is the constant value into F2. Here F2 means, you can already know that the real part of permittivity, that indicate by E prime. Another one is, next one is E double prime. E double prime, imaginary part of permittivity. So how can we calculate this imaginary part of permittivity? You can see here equal I2 into F2. Here I2 indicates the tan delta value into F2. Here F2 means the real part of permittivity. So using this formula, you have to easily get the E double prime. E double prime means imaginary part of permittivity. The conductivity, another parameter. This is very interesting calculation. You can see here conductivity measurements. For conductivity measurements, you have to need H2. Here H2 means conductance. Here is the difference between the conductance and conductivity, not same parameter. So you have to need the conductivity. You have to measure this measure this conductivity using this formula. Here H2 means the conductance into, this is the 0.001382. This is the diameter of your pellet, and 0.000134 is the area of your pellet divided by area. If you use this formula, you have to calculate easily the conductivity of your pellet. Then you have to see here the two parameters, Z prime and Z double prime. Z prime indicates the real part of impedance, and Z double prime the imaginary part of impedance. So how can you calculate this Z prime? Here you can see equal cos J2. Here J2 means, you can see here the E double prime. E double prime means imaginary part of permittivity. So using this calculation, you have to convert or calculated this Z prime, real part of impedance, and this is the imaginary part of impedance. You can use equal sin Z2 into K2. Here K2 conductivity. And this is the modulus J M prime and M double prime. This is a modulus. So to calculate this modulus, you have to need this formula G2. Here G2 means 2 pi f, and M2, here M2 means Z double prime and 8.85 into 10 inverse 12. And for M double prime, you have to need this formula. Just you have to G2 into L2. Here L2 means Z prime and 8.85 into 10 inverse 12. This is a constant value. So using this formula, you have to calculate of your electrical data easily. Here is the pellet area. This is pellet area. This is the radius, and this is pellet diameter. This is the sample 1, sample 2. In this way, you have to calculate another data. So if you want to using this data and make a beautiful graph, you can see here the beautiful graph here. Frequency versus conductivity, frequency versus tan delta. In your origin software, you have to need to wait for the next video. If you have to need to other video and likes my channel or video, please hit the like button and subscribe my channel. Thank you and best of luck everybody.